So now we're gonna talk about differential calculus. So what we're going to do right now is to get the first derivative of this expression. So first thing first, we're gonna equate this expression into y. So now we can clearly see that we can derive this equation in terms of x. What I'm trying to say is like this, dy over dx. So simply means that the derivative of y with respect to x. So we can clearly see now that our y is actually the whole thing here, which is the square root of x squared minus 4 over dx. So now, before we proceed, so we will just remember that we can actually reform this expression into the other form. So what I'm trying to say is like this. They are actually the same. So now we can do like this. So now, upon observing, we can actually say that we can use a power rule in this kind of given expression. So power rule. So let's just recall about power rule. Recall. So the formula of power rule look like this. U to the power of n over dx is just simply equal to n times u to the power of n minus 1 and the derivative of u. So now, before we deal with our formula, so first we're gonna list down the most important part of our expression in terms of this given formula. So u to the power of n, this is actually our u, the whole thing here, and then this is the power n, so which is 1/2. So just listing it down like this. Our n is 1/2, something like that, and then our u is the whole thing here, which is the x squared minus 4. So now here we are. So what we are going to do is just follow this what the formula says. So first is n. So our n is actually 1/2, as what we can say our given values and expression. So our u is this whole thing, x squared minus 4, and then n minus 1, or just simply say 1/2 minus 1, and the derivative of u, which is our u is actually this whole thing here, x squared minus 4, and with respect x. So now in this side we will just do some algebra in here, and in this side we will do the derivative. So 1/2 x squared minus 4, then 1/2 minus 1 is just simply negative 1/2. And now in this side we can actually use distributive property. What I'm trying to say is we're gonna distribute the derivative into each term of the expression. So just look like this. And actually this whole thing here, we can actually bring this down, okay, to eliminate the negative sign. So what probably I'm gonna do is like this, 1/2, and then bring this thing all down, x squared minus 4, and then 1/2, so to eliminate the negative sign. So now in this side, what we're going to do is use the power rule. So as what you can see, as what we used earlier, we use the power rule. Same thing what we have done in this area. So this is our u and this is our n. So just simply like this, 2. So our n is 2, so just put 2 there, and u is x, and then n minus 1, which is 2 minus 1, and then derivative of u. Our u is just simply x, so dx over dx. So in this area, as what you can recall, the derivative of a constant number is always 0, so we'll just simply put 0. And now we can actually bring back this expression here into its original form, which is this one. So like it's look like this, x squared minus 4, and this one is we'll just do some algebra in here. So 2x, 2 minus 1 is just simply 1, or just we will just ignore it, we will never put anything, and then the 0 is nothing, just leave it behind. So now the thing is, what you can actually observe is we can actually cancel this to here, and then the x is, we will just multiply it, or just put it inside, look like this. So square root of x squared minus 4, and actually this is our first derivative, or we will just copy our indication right there. So x squared minus 4 1 half over dx, or just simply the original form, which is actually like this. Square root of minus 4 over dx is our answer is x over square root of x minus 4, something like this. So this is now our first derivative in this given expression. Don't forget to put actually the right here, just put each of them, but we will never do something like that. That's all.